Okay, defenses. How do you stop this CSRF attack? So it turns out most of the CSRF defenses end up being server side. This means that the server is the one that's going to do the work to defend it and not necessarily the browser. So we'll look at two different defenses that help us stop this attack. So if you think about the problem with CSRF, the name itself sounds pretty fancy, but it's not that complicated of an attack. It's basically just tricking the user into doing something they didn't intend. And the reason why the attacker was able to trick the user into doing something they didn't intend is because the user was automatically attaching the cookie. So the attacker, when they craft the malicious request, in the analogy, it might be something like writing this malicious check. The check just has to say who you're paying money to and how much money you want to pay. If we look at some of the malicious requests we made, it was just some URL that says transfer $100 to Mallory. So all of the requests that we've seen so far that execute CSRF involve some request where an attacker can easily forge it. That's the F in CSRF, forgery. The thing you want the victim to do, you can write out that request, and it looks indistinguishable from the user who actually wants to make that request on purpose. So in the analogy, if I rewind a little bit, the check that you write would look the same as the check that the stranger writes. That's the problem. The stranger is forging a request that looks like it's from you, and the only authentication comes from the cookie that your browser automatically attaches. And same thing here. Whether you want to send Mallory money on purpose or whether you're tricked into sending money to Mallory, both of them are done using the exact same URL. So Mallory can forge the request, and it looks indistinguishable from someone who actually wants to transfer money to Mallory on purpose. That's the forgery in CSRF. So to stop CSRF, we're going to make it harder to forge those messages. So far, all the messages have been very easy to forge. You can write a fake check in the analogy. You can use that URL that looks the same whether you're doing it on purpose or whether someone has tricked you into making that request. So the way to make these requests harder to forge is to add another secret value that the attacker doesn't know. So for example, maybe in the analogy, instead of any check being accepted by the banker only accepts checks if they have your top secret number on it. Let's say it's your birthday. So for whatever reason, the bank has a new policy and it says, I only accept checks if you write your birthday at the bottom. Okay, now if the attacker tries to pass you a secret piece of paper and say, send this to the person besides you and it's the bank, the attacker doesn't know how to write that fake check because the attacker doesn't know your birthday. So by adding that secret value, it is now harder to forge the fake requests, and only the user who wants to make the request on purpose can write their birthday and then write an authorized check. So that same idea applies on the internet as well. A CSRF token is some secret value. It's different from the cookie, but it's some secret value that you have to put in a request for that request to be valid. So this makes it harder for the attackers to forge the cookie, or not the cookie, the request, because the attacker can no longer just write a URL or write a fake check that looks the same, whether you're tricked into doing it or whether you're doing it on purpose. The person doing it on purpose will know the token, and the attacker making a fake request will not know this token. And again, this token is separate from the cookie, and it's not automatically attached. You have to attach it using something that's not a cookie. So for example, maybe add it as one of the arguments in the get URL. So instead of money equals 1,000, 2 equals Mallory, add a third parameter that says birthday equals this, or CSRF token equals this. And now the attacker doesn't know how to craft that malicious URL for you to click on. So it's a new token that we put somewhere else separately from the cookie. So here's another example of CSRF tokens besides the ones we've talked about, where you put the birthday on the check, or you put the extra URL parameter in the transfer money link. Another example of a CSRF attack is filling out forms. So for example, if the attacker wants to get you to fill out a form with malicious data, maybe what they'll do is when you visit evil.com, if you're tricked into visiting evil.com, the attacker will write some JavaScript that automatically fills out a form with all the fields filled out maliciously and sends a post request with the form filled out. Now, CSRF tokens will stop this by saying it's not enough to just send the form with the cookie, because anyone can trick a user into making that request. They just fill out the form, the user automatically attaches the cookie, and the user has been tricked into making a request that looks valid. Instead, what we'll do is we'll say this form actually has an extra field. It's not enough just to fill out the form. You also need to fill out the last field, which says, what is the CSRF token? And you need to answer that field correctly in order for this form to be accepted. So now if the attacker writes a bunch of JavaScript to make a fake form that they fill in for you and send out, they will not know how to answer that last question, what this CSRF token is. The user knows the CSRF token, the attacker doesn't. So a user making a legitimate form submission will know how to answer that question, and an attacker who doesn't know the token will not be able to forge a form submission that looks like it's from the victim. Now, the attacker could try to get their own token, but it would be different than the one that the user is using. Everyone has separate CSRF tokens. Now, you might be wondering why you never have to type the CSRF token. And the reason is because modern browsers and servers will usually do this for you. So they'll send you a CSRF token, and it'll be pre-filled in some hidden form field. So the browser usually hides most of this from you. But this is the idea behind using CSRF tokens. It's adding extra fields to make it harder to forge requests. So here's an example of a CSRF token in picture form. So first you log in, and you get a cookie. But not only do you get a cookie, when you request a form, you also get that top secret token value. So now you have two secret values, the cookie, which is automatically attached, and the token, which you must attach yourself, or the browser will fill in the form field for you. So you request the login, you get the cookie, you request the token and the form, and you get the token. And now, if the attacker wants to send you a pre-filled form using JavaScript and make you submit it, the attacker doesn't know what to fill in for the last question. What is the CSRF token? You know it. The attacker doesn't know it. They don't know how to manually fill in that field because they don't know the token. They could try to get their own token, but that would be a different one in red than your token, which here is in green. So that wouldn't work. The user would make the request, the cookie would get attached, but the server would say, nope, this token is wrong. You have sent a red token, and the answer is the green token, so this request is rejected. We've made it harder to forge those fake forms by using an extra field that has to be filled in.